Another thing that you'll be asked to do tomorrow night is have something scraping across the pavement. And we can ask you, how far does it scrape before it stops? Or how many seconds, according to your Mickey, does it scrape before it stops? These are fundamentally different problems with different solutions. If I want to know how far it slides, I use energy. Okay? Now, if it's a level road, I don't have to worry about gravitational energy. There's no springs. So when I say energy, I mean kinetic energy. And it had some kinetic energy, and then it scrapes to a halt, and it has no kinetic energy. This negative there is negative because the friction is acting one way, while the motion of the car is the other way. And by definition, that's negative air. Now, you'll notice, this is an aside, you notice I haven't put all the equations up on the board today. I just assume it's the day before the exam. You've got those memorized. Because tomorrow night, you're going to have them memorized. If you look at the sample exams I gave you, the few equations that are on the front page of those sample exams are the few equations you're going to be given tomorrow night. And if you ask the proctor for anything that's not on that page, they're instructed not to give it to you. Okay? You have to have those memorized coming into the exam. So let's plug and chug here. If the mass is 500 kilograms and it's moving 20 meters per second, then I can solve for the kinetic energy. If I know the mu sub k is a half and the normal force is 5,000, then the friction force is just going to be 2,500. I solve for delta x and I get 40 meters. If I want to know how much time it slides for, that's a momentum problem. Energy never tells us about the time. That's just fundamental. Okay? So the initial momentum is m times v. When it comes to a halt, it has no momentum. And what bleeds away the momentum is the impulse, the friction times the time. And that's negative because it's pointing in the negative direction if I'm calling the direction of the velocity positive. If I plug in my values, I get a delta t of 4 seconds. Again, you should be able to do that without breaking a sweat. Now, if the car is going 20 meters per second when the brakes are hit and it screeches to a halt, what's the average velocity during that 4 seconds? It's not the fastest of 20. It's not the slowest of 0. What is it? It's 10 meters per second. And if it covers 40 meters in a time of 4 seconds, its average speed was 10 meters per second. So it makes sense, does it not?